Hey everybody, so what we're going to do is go through some vocabulary words that we are going to need for our Unit 1 test. We've used these words in class, but I want to make sure that we have got them down and we understand what they mean. So several times we have said the word point. We've used it, we've used it, we use it. Now, the word point really doesn't have any definition. Usually, though, we represent a point with a dot. This is a point because it is a location in space. We always name points with capital letters. So this could be point A. I'm going to call it A because it's the first point. Now, this dot right here is way bigger than that dot actually is. It is infinitely small. Points have no dimensions. It is so tiny, we can fit a bazillion points right there. And we never know which one it is. If I add another point, I have to change letters because that's location A. This is going to be location B. Down here, I could put location C. I can actually name them any capital letter I absolutely want. So every time I do a new point, I use a different letter and a different capital letter so I can represent a different location in space. Now, what do we do with points? Well, we put points together and we make shapes. And we make shapes by making lines. So if I start with 2 points, let's start with point A, location A, it's a capital letter, notice, and I'm going to have point B. Anytime I give you 2 points, what I am allowed to do now is I can connect these points with a line. This line is infinitely long. It has one dimension, length. It's long. All it is length. It is not that wide at all. And to name this line, I would call it line AB. It has 2 arrows on top because it goes on forever. Or I could call it line BA. Either way works. I could also, if there was a lowercase letter right beside it, we could also call this line M. So all of those are ways to name our line. Now, if we look at just a piece of that line, that's a segment. So if we go back and we look at line AB again, point A, point B, once I have 2 points, I'm allowed to connect them with a line that goes on forever. Now, a piece of that line is called a segment. So if all I'm concerned about is this piece, that is segment AB. Again, it has length, but it's not infinitely long because it starts at A and it ends at B, segment AB. So we'd call that segment, notice there's no more arrows on it, AB, or I could call it segment BA. This means segment because there's no arrows on top. Another way I could do a part of a line is I could make a ray. A ray starts at a point. So we're going to give that ray a starting point. And then we're going to give this ray a point to go through. And if I start at A and I go through B, it doesn't matter how it keeps just going. This would be ray A, B. If I switch it around, let's do another ray. Let's give ourselves 2 points. Let's start at C and go through D. If I go this way, now watch how I write this one. This is still going to be ray C, D. Notice this arrow is still pointing to the right, even though the arrow went left. That's okay. Arrow goes to the right. Start with the letter our end point, which is C, go through D. Infinitely long again. And then sometimes I'm going to give you opposite rays. An opposite ray is a ray that's going to, both rays are going to start at this point, and I'm going to go this way. Let's call this ray AB. And then if I have a point on the opposite side and I go through it like this, let's call this D. Why D? Why not D? So you can see we have ray AB and I have ray AD. Those are opposite rays. And notice they make a line. Opposite rays always create a line. You're going to need to know opposite rays for your test. It's listed all the time. Opposite rays. They both started at A, because you can see by the names. One goes to the right through B. One goes to the left through D. Collinear, not a new word. We've talked about it before. Collinear are 3 or more points that are all on the same line, or that I can connect with the same line. So if I give you 3 or more points, A, C, F, these points are all collinear. I can keep adding points, H. All these points are collinear because they are all on the line. A, C, F, and H are all collinear. They are collinear because every one of them is on this line. By the way, to name this line, you're only going to use 2 letters. We only use 2 letters to name this line. So if I was going to name this line, I'm just going to pick 2 letters off of it, any 2. I don't care which. So I could call this line FH. Just pick 2, because you're going to lose points on the test if you pick more than 2. Non-collinear is if we go back to that same diagram. Let's say I have a line and I have some points on that line, at least 3. A, C, D. Why not A, C, D? And then I put a point not on that line. Any group of points that has E in it is non-collinear. So if I say A, C, D, and E, because now I'm including E, A, C, and D are collinear. As soon as I bring in E, these are non-collinear. And it's non-collinear because E is not on the line. If any point is not on the line, it's non-collinear. And again, another way to name this line, pick 2 points. I don't care which 2, and I don't care which order you write them in. So we could call this line DA. Now, a plane is a collection of lines. A collection of points is a line. A collection of lines is a plane. So a plane, what we're going to do is we're going to make a flat 2-dimensional figure. So basically, any 2-dimensional shape, a rectangle, a square, a triangle. And notice that's at least 3 points. 1, 2, 3, 4. And I can trace the shape. I can trace the shape with those 4 points. So if we call this A, B, X, Y, this would be plane A, B, X, Y. Or ABX or BXY. You need at least 3 letters. 3 letters. Any 3 letters can name the plane. So ABXY, that would be a name. You could call it BXY, 3 letters. Let me say it's a plane. Or if the plane has a capital script letter on it, you can name it that capital script letter. Plane, script, plane R. Now, intersecting is when our items cross. So if 2 lines cross, or 2 segments cross, or a segment and array, or that cross, they always cross at a point. So if I've got lines, segments, or arrays, they always cross at a point right there. If a plane and a line intersect, they intersect at a point. If you're looking at this diagram right here, line L intersects plane V at R. There's a point. It intersects plane W at Q. And when planes intersect, they intersect at a line. The pink plane and the green plane intersect at this line right there. And I extended the line because the planes actually go on forever. Now this was just a down and dirty part. We're going to go over this more in class. I understand that there may be some questions, and that's okay. But I needed to get this out. We can answer our questions in class because that's where we do our practicing. We do our math. So if you've got any questions that are burning in your head right now and you need to get them down, please jot them down. Come into class tomorrow. Answer those bell work questions that are currently available. And I'll see you when I see you, Patriots.